Right, this is our topic 7, absolute value inequalities. So we're going to be combining our knowledge of absolute value equations versus solving inequalities. We're kind of meshing it into one. So the first thing that I want to talk about is when we have different signs. So before, when we were looking at inequalities, we were thinking either a solid or an open circle. Now we're going to look at the inequality signs based on if they're less than or greater than. So if we have the absolute value of something is less than or equal to some number, that means it's going to be an and statement. If we have the other case, anything greater than or equal to, those are going to be our or statements. So let's look at the first example. So we have a greater than or equal to sign. So that means we are going to be looking at an or statement based on what we have written above. Now that we've decided it's an or statement, it's time to split up into our two different cases because it is an absolute value equation. So the first one is set equal to the positive. Our second is going to be set equal to the negative. But what we have to remember, so it's -5 now, is that when we multiply or divide by a negative, we flip the sign. So that case holds true. So one side of the absolute value is going to be what you see above, just without the bars. The other side flips the sign and makes the right side negative. So let's go ahead and solve both of those inequalities. Right, so because we said it was an or statement, we can go ahead and put our critical numbers on. So -6 and +4 are critical numbers for this number line. We're going to be using closed circles because both of them are or equal to. So less than or equal to -6, 6 with the arrow going to the left, and greater than or equal to 4. Because it's an or statement, whatever we have graphed, it's one or the other or both, that's going to be our solution. Second example. We have a less than sign, which means if we look at our notes above, we are going to be doing an and statement. So let's go ahead and split it up. So our first one and our first equation is just like what we see above. We just dropped the absolute value bars. Our next one, remember to flip the sign and make it negative. Go ahead and solve both. We do have some fractions, but that's okay. We just have to remember to make our tick marks whole numbers on the number line and remember that it's an and statement. So 5 halves is 2.5, so we're going to need a 2 and a 3 on the number line, and -1/2 is between 0 and -1, so we need a -1 and a 0 on the number line. We are going to be dealing with both open circles. Our first one is P is less than 5 halves, so open circle at 2.5 going to the left. Our next one, open circle at -1/2 going to the right. Because they're going towards each other, that's where they overlap, so we can actually just connect it and make it a little line segment, and that will be our final answer. Third example is actually kind of a trick question. Let's hold on for 1 second and talk about this. Can we have an absolute value of something be negative? No. Can we have an absolute value of something be less than -2? No. So the absolute value of something cannot be less than 0. Therefore, this has no solution. We don't even need to solve it. So if you can look at the original equation and see that it's never going to be less than or equal to -2 because it can't even be negative at all, there's no solution. There's no need to go ahead and do all the work just to come to that conclusion. All right, our last example is a little bit more complex because we do have a little something extra. And you can only split up into your two absolute value inequalities if the absolute value bars are by themselves. So we first need to get rid of everything outside of the absolute value bars. So that -2, we have to undo that by adding 2 to both sides. So let's go ahead and do that. Because we have to get the absolute value bars by themselves before we can split up into two inequalities. Once we add 2 to both sides, we have our new absolute value inequality, which now we can split up into our two inequalities. Again, don't forget, flip the sign, make it negative on that right side. Go ahead and solve both. Right, and then I forgot, we have a less than sign. in the original. So what does that mean? Is it an and or an or statement? It's going to be an and statement. So let's go ahead and graph. Because we have fractions, again, we still need the whole numbers. So going from -1 to 2, increasing by 1 will work perfectly. We are going to have open circles, and then 5/3 is about 1.7. So we need an open circle at 1.7 and an open circle around -0.3. So here's the graph of greater than or greater than -1/3. And now let's graph less than 5/3. Open circle at 1.7, draw it to the left. And again, they're touching, they meet, so that means it's going to be a line segment connecting the two. And that is our final answer. Thank you for watching.